Hi everyone, let's solve today's daily challenge, that is minimum distance between BST nodes. So in this question, we are given the root of a binary search tree, BST. So what is a binary search tree? In a binary search tree, the root of the tree, right, its left children are less than the root and its right children are greater than the root. So such a binary tree is called a binary search tree, right? Now what we have to do, we have to return the minimum difference between the values of any two different nodes in the tree. So for example, we are given this tree here, right? So we can consider any two different nodes. So let's consider 4, 6. So the difference between these we will be getting as 2. So one thing to notice here is the difference that they are talking about in the question is the absolute difference, right? We don't have to care about the positioning. We can take any two nodes of this tree and we have to calculate the minimum difference that we can get out of them. So for example, if you see 2 and 6, so if they had asked the maximum difference, so 2 and 6 would have yielded a difference of 4, right? So which is the maximum difference, but we have to consider the minimum difference. So that I only told you that we can consider 2 and 6 also as two roots of this tree, right? And we can also calculate the difference between them. So if you consider all the pairs after choosing all the pairs, you can see that 2 1 and 2 3 will give us a difference of 1, which will be the minimum out of all the pairs, right? So the output is 1 in this case. Similarly, for the second question, this is the tree that is given to us. So we have 1 0 48 12 and 49. So the minimum difference, if you see here, is we will be getting using 1 0 or 48 and 49, which is again in this case is 1. So that is the minimum difference, right? So let's see how we will be solving it. So you might be thinking of doing a traversal, right? For example, if you consider this tree, so this is the pre-order traversal for this tree, right? So after doing this pre-order traversal, you will be storing this in an array, right? So what you will do, you will do two traversals, right? That is one for loop to consider the first element of the pair and the second for loop to consider the second element of the pair, right? So then the time complexity will become O of n square, right? If you try to consider all the pairs, right? Now can we reduce this? Can we reduce its complexity? So you will say that yes, we can reduce, right? So how can we reduce? If we like, why should we consider all the pairs, right? I can already see here that 48 and 0 is of no use to us, right? We will be considering 1 0 or 48 and 49, right? So if you see, if I just sort this, what will I get? I will get 0 1 12, right? And 48 and 49, right? This is what I will get after sorting this, right? So if you see, if I pair 0 with 1, that is correct. But why pair 0 with elements greater than 1? Because we need the minimum difference. So why pair with these elements, right? Similarly, for 1, if you see, if we pair it with 12, that is okay. But if we have to pair it with numbers greater than 12, then we don't have to do that, right? So that is why sorting this particular traversal makes sense, right? So after sorting this, we can easily take the two adjacent elements and calculate the difference between them, and we can take inside of another variable, we can store it, the minimum values, right? So that is how we can do it. So but if you see, if you do any pre-order or post-order traversal, or let's say if you do BFS for this particular tree, you will have to sort it. So sorting this particular array will take O of n log n, right? We will be taking O of n log n. But can we reduce it? Can we reduce it more, right? So if so there is a property of this binary search tree that if you traverse it in order, right, you will be getting a sorted array, right? So let's do that. So in order considers what? Left, root and right. That is what in order traversal is. So what you will take first? You will take the left, then the root, then the right. So right we have here. So in order traversal is a DFS. So we will be considering this node, right? So we'll be considering 12 here, and after that we will be considering the root and the right, that is 49. 9. So if you see, this is an in order traversal which has given us a sorted array, right, which we need, right? We need to sort the array, but we already got the sorted array by doing the in order traversal. Now we can easily, so in order traversal will be taking O of n, and also to calculate minimum we will be taking O of n. So total we will be having O of n time complexity for calculating the minimum difference between any two different nodes in this particular tree, right? So that is the logic, that is we have to sort it because we don't have to consider other pairs, right? In which if you have considered 0 with 1, right, we don't need to consider 0 with numbers that are greater than 1, right? So we can simply take the adjacent elements and then we can easily calculate the difference, and these adjacent elements will be yielding us the minimum difference only. So let's now code it. So what we'll be doing, so let's create our vector int traversal here. Traversal, let's call it traversal, and also let's create our answer variable. Let's initialize it to int max, and after that we will be creating a function for in order traversal. So in this function we'll be passing the node, right? That is, sorry, here we don't have to write node, we will be passing the root of this tree, and we will be passing this vector, that is traversal, right? After we get the all the elements in this vector, that is the in order, we will be getting a sorted array. So what we will do, we will simply have a for loop, right? Let's go from 1 because we have to consider the pairs. Traversal dot size and I plus plus, and what we will do, we will simply consider the adjacent element. So ans will be minimum of ans and traversal of I minus traversal of I minus 1, and we will be considering the absolute value. So we will just put ABS here, otherwise we'll be getting a wrong answer. This, and we will simply return this ans. Let's also write the logic for in order traversal. So that's easy. What you have to do, we will be writing a recursive solution. So first you call for the leftmost side, then for the root you take the root, its value, and then you make a recursive call for the rightmost part. So we will be having in order, and here what we will have tree node, let's call it node, and also let's have our vector here. Vector is vector int, let's call it traversal. Okay, now what we will do, we will check if our node that we have, it is not equal to null, right? Then what we will do, we will make a recursive call to the left part of this tree, right? So we will be moving towards the left, and here inside of this vector traversal we will be pushing back the value of this particular node, that is this, and after this we will be calling for the rightmost part, that is this, right? So this is the logic for in order, and here we have written our logic to calculate the minimum difference, right? So let's quickly run it. Okay. Okay, we haven't passed the array here. Let's also pass the array. So, and also let's pass the array here. Traversal. Okay. Okay, so it's accepted. So let's quickly submit it. So that is how we have to solve this question.